And the final piece of this puzzle is persistent volume claim. So this is how it looks like. This is the manifest file. The kind is persistent volume claim, and metadata is pretty straightforward. Under specification, we have access modes. So this access mode is similar to persistent volume. Instead of once, I can mention many also. So there can be three options: read, write many, read, write once, and read only. Then you have volume modes, which tells you that whether you want it as a file system or as a block device. There can be two options. One is file system and the other one is block device, similar to persistent volume. Then in resources, we mention request, like how much of storage do I want. So I'm mentioning 3 GB here. We cannot have more than what that we have in our persistent volume. So let's say I have a persistent volume of size 30 GB. I cannot create a persistent volume claim with 40 GB. I mean, we can create, but the problem is that the claim will not be respected because the amount that is needed is more than what is actually there. When you create the persistent volume claim, the object will be in pending state. And then finally, we have the storage class name, wherein I have mentioned the storage class that we created earlier. As I said, this storage class will manage the dynamic persistent volume, and for that we need a cloud service provider association, which we do not have. Which means that if I use this persistent volume claim, it should fail because it will go to the storage class, and storage class will try to offload the responsibility of giving this 3 GB of data to this persistent volume claim, but it can't because there is no cloud service provider plugin that we have mentioned while creating this cluster. Let us go ahead and try to create this persistent volume claim. Alright, so the persistent volume claim has been created. Let us go ahead and try to see whether it actually has been created or not. And it says that the status is pending. Now before I troubleshoot, let's see whether we have the persistent volume claim in other namespace or not. Now here's an interesting part. Persistent volume claim are namespace based because this will actually be used by a pod. And as pods are scoped or limited to a namespace, so does a persistent volume claim. So out of all the three components like storage class, persistent volume, and persistent volume claim, storage class and persistent volumes are the only ones which are non-namespaced, and persistent volume claims are always namespace based. So if I describe it, this is the name, we have namespace, the status is pending, volume mode is file system, and see the reason. It says that the provisioning failed, and we are getting the error message from persistent volume controller, and the message says that failed to provision volume with storage class this, invalid access modes, only access modes is read write once are supported. Okay, this is something I did wrong. I should change this to read write once. That is the only access mode that is supported. So I have deleted the previous one. Let us try to create this persistent volume claim again. It has been created and it is still in pending status. Let's see the problem this time. And this time the error is something else. It says that failed to provision volume with storage class followed by the name of the storage class, failed to get AWS cloud provider, and the get cloud provider call returned a nil value. This is obvious because we do not have any AWS cloud provider plugin available which can go ahead and give us this persistent volume, which is asked by this persistent volume claim. Now, as I said, we can fix this error by stopping the cluster and restarting it with the cloud service provider option. Let us not go ahead and do that. What I'll do is that I created this persistent volume in the previous lecture, which was manual, which was not being managed by the storage class. So I'll create a persistent volume claim which will use that persistent volume rather than using the storage class. So let me delete it first. It has been deleted. And the other persistent volume claim that I want to use is this one, read write once. Everything is fine. The only difference is that the storage class name is manual rather than the storage class that we provided. That means that the persistent volume claim will use the persistent volume that you created manually to get this storage. Let me go ahead and create the persistent volume claim, and now if I do a get PVC, it says pending. Alright, I made a mistake. I had to create the persistent volume again. As it is a manual one, I cannot mention read write many. I had to revert it back to read write once. And the same thing has been done for the access modes in persistent volume claim as well. Now let's go ahead and create the PVC. And now if you see, the persistent volume claim has been created and it has been bound to the persistent volume K8s storage PV. See the status, it shows us bound. Let us go ahead and describe this PVC. And if you see, the namespace is default because PVC is limited to a namespace. The status is bound and has been bound to the volume or the persistent volume K8s storage PV. The access mode is read write once and the volume mode is file system. One more thing to note is that let's say you delete this persistent volume claim and you are using storage class as manual. So if you delete this persistent volume claim, make sure to delete the persistent volume also, and then create the persistent volume and then create the persistent volume claim. Now this is only for if you are doing it using the storage class manual. So let's say if I want to create it again, let me just show you. So let me go ahead and delete this PVC. So the PVC is gone. So if I create it again and try to do a get PVC again, it says pending, and the error would be pretty different because we'll not be able to make sense out of it. Now if I do a describe PVC, it says that the storage class storage.k8s.io.manual not found. Now to solve this is to delete the PV again and then create the PV and then create the persistent volume claim again. Now if you do a kubectl get PVC, everything works as usual. And this is only true if you are using storage class to be manual. So you don't have to worry about it if you are using a dynamic storage class by a cloud service provider. Now the final thing is that how does an application uses this? So I have this deployment which actually creates an Nginx pod, and this is how you associate the persistent volume claim to an application. So here, see here the volume blocks or the volumes block. The name is K8s storage volumes, and I'm associating the persistent volume claim with the name of it. Now I'll have to mention the volume mount in the container also. And this is how you mention the volume mounts. I'm saying that the mount path in the container would be /home/apps/data, and the name is K8s storage volumes, which is nothing but this name of this volume, which is associated with the persistent volume claim. So let us go ahead and deploy this application. And let's go ahead and create the deployment. The deployment has been created. If everything is fine, there should not be any problem, and the deployment is up and running. This is the pod and this is the deployment and this is the replica set. Let us go inside of this pod and see whether the volume has actually been mounted or not. Alright, I'm inside of this pod, and if I go to home, I should be able to see this apps and data. So seems like I have home apps data mounted. So do a pwd and okay, I'll go to data and do a pwd. So I'm inside of this directory home apps data, and if I do an lsblk-p, so if you see /home/apps/data has been mounted inside of this container, which is running our Nginx application. One more way which can be used to find the volume mounts inside of a pod is using the describe pod command. If I describe this pod, everything is normal, but take a look at this mounts option. So there are two things. The first one is /home/apps/data from K8s storage volumes. It means that this pod contains a mount point, home apps data, which has been created from volumes, K8s storage volumes. Now this K8s storage volumes is associated with the persistent volume claim that we created. So there's one more option which talks about something called a service account untoken. We'll discuss it in the next section, but here I want to show you this option only. You can create multiple mount points also using multiple persistent volume claims. So using this describe command also, you can get information about all the mount points that you have inside of a pod and the containers, and where those mount points have been created from. So in this case, it has been created from K8s storage volumes in the volumes section of the deployment file. And from there you can get the persistent volume claim name, and then you can trace it back to the device or the persistent volume that you created. So this is how it works. The first thing that we do is we create a storage class, and in the storage class we mention a provisioner which has an association with the cloud service provider, and then we create a persistent volume. If we do not have any cloud service provider, we use manual, or we do not create the storage class at all. Then we create the persistent volume, and in the persistent volume you mention the storage class name. So if we do not have the storage class associated with any cloud service provider, we mention the storage class name to be manual, and from there we create a persistent volume claim with the storage class name to be manual, and then we ask for some volume. So once we get that, in the deployment or in the pod template, we mention the persistent volume claim in the volumes section, and in the container section we mention the volume mounts. So this is how an application gets hold of a persistent storage whose life cycle is completely different than that of the life cycle of the pod itself. So even if the pod dies or goes down, the application will still be able to write data in it, and the data will be saved because we are using an external storage device to store the data which is written by the application inside of the pod. So that's all about storage. We created a deployment using nginx image. We created a persistent volume with manual storage class, and we just created a storage class with AWS EBS provisioner. We did not use it though. Then we created a persistent volume claim using manual storage class, and then we attached that persistent volume claim or attached the volume using the PVC in the above deployed pod.